Okay, so taking a look at the first part of rational expressions, there's a couple of terms we need to know. First is algebraic fractions. So when we're talking about algebraic fractions, it's going to be the quotient or division of two algebraic expressions. So like -4 over root x minus 2, t over 5, x squared over 3y squared, or root 3x plus 1 over x squared. Not all algebraic fractions are rational expressions. The difference is once we get to rational expressions in an algebraic fraction with a numerator and denominator that are polynomials. And this is going to be really important. They have to be polynomials, where we know that a polynomial is going to be an algebraic expression formed by adding or subtracting terms that only have whole number powers of variables. So we have a couple examples of this. 1 over x squared, m over m plus 1, y squared over y squared plus 2y plus 1, or x squared minus 4. Where, in this case, x squared minus 4 can be considered a rational expression because that would be the same as x squared minus 4 over 1. So we could express it as a ration. All rational expressions are going to be algebraic fractions. For non-permissible values, it's any value for a variable that makes the expression undefined. So if we substitute a variable into the variable and try and solve it, we're going to wind up with that error on our calculator. In a rational expression, anytime that I have a value for the variable that results in a denominator of 0, I can't divide by 0, so it's not going to work. These are known as restrictions on the variable, and the restrictions must be determined before simplifying the expression. So after we simplify the expression, we might wind up eliminating some of the restrictions. We need to do it before we start canceling things out, which we're going to take a look at in a second. So if I am circling the expressions that are rational, the first thing I'm going to do is I'm going to look for expressions that are not rational and justify why. Well, in the first case, if I have 1 over root x, this is irrational. Because I know that root x is going to be the same as x to the power of 1 over 2, and that is not a whole number power. If I take a look at the second case, 2x plus 1 over x to the power of 3 minus 2x squared plus x to the negative 1 plus 3. Well, as soon as I see that x to the negative 1 is not a whole number, so this is not rational. When I take a look at the third case, if I have root 2, and it's very important to see the distinction that it's just root 2 multiplied by x, it's not root 2x, minus 1 over x to the 4 plus 3x squared minus 7x, that one is rational. It follows all the criteria. When I get to the fourth example, I can see right here, cube root of x would be the same as x to the 1 over 3, which is not a whole number. And for the last one, I have 1 over 2 is a polynomial, so that one works. All right, for each rational expression, we're going to determine all the non-permissible values of x. Well, kind of like when you're looking for restrictions and radicals, in this case, I'm just going to say that what's in the denominator can't equal 0. So if I take a look at this, I can say that 2x minus 3 cannot equal 0, which means that my non-permissible value is going to be that x cannot equal, when I isolate x, 3 over 2. In the second case, if I have x squared minus 5x plus 6 in the denominator, I'm going to say that x squared minus 5x plus 6 cannot equal 0, which means that x minus 3 times x minus 2 when I factor it cannot equal 0. And my non-permissible values are going to be x cannot equal 3, or 2. For example C, if x squared minus 25 can't equal 0, then x plus 5, x minus 5 cannot equal 0, and the MPVs are going to be that x cannot equal either positive or negative 5. And in the last case, if x minus 1 can't equal 0, then my non-permissible value is going to be that x cannot equal 1. If I am stating the restrictions of the variable a for the following rational expression, well, restriction is the same as saying what are my values going to make this possible, so it's going to be the same as looking for my non-permissible values. So in this case, I'm going to say that a to the power of 3 minus a squared minus a plus 1 can't equal 0. I'm going to factor by grouping, and I'm going to say that I'm going to have a squared and a minus 1. In order to make the second one match, I've got to take out a negative 1, and a minus 1 cannot equal 0, or a minus 1 and a squared minus 1 cannot equal 0. Well, I can still factor down the second set because it's the difference of squares. I'm going to state that a minus 1, a plus 1, and a minus 1 cannot equal 0. Now I have two cases here that are the same. I have a minus 1, which would give me a can't equal 1, and I have a minus 1 where a can't equal 1, and then an a plus 1. I'm not going to state repeated ones. I'm just going to state that a cannot equal positive or negative 1. And there's my restriction. All right, when we're looking at simplifying rational expressions, we're going to follow these steps. First, I'm going to factor the numerator and the denominator if that is at all possible. Then I'm going to state all the non-permissible values before simplifying. And then I'm going to cancel out any common factors from both the numerator or the denominator. So I'm just going to simplify these fractions. So for the first one, I can state, just looking at the bottom, if it's 6 times a times b, that my non-permissible value is going to be that a can't equal 0 and b can't equal 0. Then I'm going to square out what I have on the top, and I'm going to say that I have 16 a to the 6 c to the 2 over 6ab, and then I'm going to simplify this. Well, 16 over 6, both of them can get divided by 2, and I'm going to say that that's going to be the same as 8 over 3. I'm going to take away the a from the bottom, so I got to take away one of the a's from the top, and I'm going to get a to the 5 on the top, and I don't have any other c, and I don't have any other b, and there's my simplified rational expression. For b, I'm going to start by factoring out the top, and I'm going to get 2 and x minus 1. On the bottom, I know that I have this 1 minus x, which is the same as negative x plus 1. If I want to make it match the factor that I have on the top here, I'm just going to divide out a common factor of negative 1 and wind up with negative nx minus 1. So anytime that you see that they're in the wrong order, then you can flip the order of this difference and add a negative outside the brackets, x minus 1. Now I can see that from a non-permissible value, if my factored form is going to be this, x minus 1, then my non-permissible value is going to be if x minus 1 can't equal 0, x cannot equal 1. Then I'm going to cancel out on the top and the bottom. Well, here's a common factor, and I'm just left with 2 over negative 1, which I can simply state my final answer is going to be negative 2. Taking a look at example C, we're going to go through the same steps. Step 1, we're going to change around the order on the top here to make sure that I have my variable first and my constant second. So I'm going to say that I have negative of 2b minus 6 over b squared minus 9. The second step is I'm going to divide out the common factor, negative 2 and b minus 3 on the top. And on the bottom, I'm going to factor that difference of squares into b plus 3, b minus 3. From the factored form of the denominator, I can see that my non-permissible value is going to be that b cannot equal positive or negative 3. I'm going to cancel out common factor from the top and the bottom. And then I can state that this is going to equal negative 2, over b plus 3. And there's my final answer. For D, I need to factor down these trinomials, and this is why we made it so important to make sure you're practicing the factoring polynomials so you can do this as quickly as possible. And when I factor down the top, I'm going to get 2x minus 3 and 3x plus 4. On the bottom, I get 2x minus 3 and x minus 2. I can solve my non-permissible values from those two factors on the bottom. And I'm going to state that x cannot equal either positive 2 or positive 3 over 2. I cancel out the common factor from the top and the bottom. And my simplified form is just going to be the 3x plus 4 over x minus 2.